Hey everyone, I'm Nancy Chauhan.
Hello everyone.
And today we are going to give a talk on enforcing security best practices using CI. So this is going to be my first talk after pandemic, and I'm quite excited for this. Short intro about me, I am a developer relations engineer at Gitpod, and previously I worked at Zeotap and Blinkit. That's where we worked together, Aseem and I, in DevOps team. And the fun fact I enjoyed the most, developing CI/CD for hardware projects. That's crazy. And I love cloud, open source, and I'm a security enthusiast. And also I love creating tech blogs, so you can check at nancychauhan.in.
So I work as a security engineer at Rippling. I don't know if you live in Bangalore, you would have seen billboards of Rippling at a lot of places. Previously I worked at Gojek. I met a few folks from Gojek here itself, and Blinkit. You might have met Vadik, he was our manager, and he might have a few good things to say about me from there. I also talk about and teach security on my YouTube channel called Hacking Simplified, not a promotion, just letting you know, and where I teach about web application security and stuff. I love to create security automation tools and research about some vulnerabilities in cloud, mostly in the cloud space.
That's awesome. So honestly, even I've learned a lot from your YouTube channel. So Aseem, why do you think our audience should attend this talk?
Because they have paid for it. One of the prime reasons. Money drives everything. Okay, let's keep the jokes aside. You would have seen this same slide coming in a lot of other security conferences and places where you see that security attacks are increasing day by day, and there's some random number where you see like, okay, 100% increase, 20% increase. We'll be also showing you some numbers, and then we'll be talking about what those are. Yeah. So this is the figure, $6.9 billion. That's from Forbes report of last year. It's just the US businesses, and even not counting the small businesses that were affected, just the major vendors and big players that were affected by some of the data breaches. And it's increasing by the number as we talk. So if you see this pie chart here, you can see there's a credential theft which accounts for 19% of it. And credential theft could be anything like, how many of you would have heard about SolarWinds 123?
Yeah, I think almost everyone.
Yeah, I see a few hands. Yeah. So SolarWinds 123 was the password for the SolarWinds hack that happened, which led to a supply chain attack I think last year it was. And it compromised around 18,000 companies. And that was part of credential theft, where a developer's credential was SolarWinds 123, and that got leaked. And eventually attackers got access to those credentials. And then there was this product called Orion, which they got access to. The second number, which has been there for ages, it's phishing. You would have seen fake websites, fake claims, and other kinds of stuff. And then comes the cloud, which is quite catching up in these places. And third-party software is where you would have seen supply chain attacks. There was this Log4j attack you would have heard, most likely. It was quite a big thing, and it also ruined our Christmas holidays as well. So I remember it quite vividly.
So definitely we have seen so much red, and I'm pretty sure in engineering no one loves red. Neither we want our pipelines failing, and nor we want our alarms raising. We want to have a better sleep, and that's why we are today here to talk about the best security best practices which you can use in your CI. So let's talk about a modern day deployment scenario. So as we know that all the teams, they ship quite faster. Let's take a simple example. If you have an e-commerce website, there are so many features which get shipped every single day, so many things which keeps changing, even if you have a sale, discount features, anything. So there are crazy rates of shipping. This is a Twitter screenshot. It was by Patrick, the CEO of Stripe. So he mentioned that they deployed 10 times a day while maintaining 99.96% availability. And they deployed almost 3,350 new versions of Stripe API last year. This tells us that this is a crazy, crazy number of shipping. And with this, we cannot leave our security behind. As you can see this screenshot, we cannot leave the security behind.
Everyone knows what happens in the end of the scene. Eventually, security catches up to deployment.
Exactly. And if you don't catch up the deployment, then there is a huge security debt. Because if you keep pushing, if you keep shipping, there will be human-prone error, and there would be, and the interaction with third-party tools would be more, like we already discussed about Log4j vulnerability. So we don't want this much high security debt. So let's start with pipeline stages. So we are going to discuss about different pipeline stages. We have source, build, test, deploy. So these are the common stages in a pipeline. And we are going to discuss how these stages are vulnerable one by one. So let's talk about the source code when you start developing your web application. Yeah, thank you. So I just want to ask someone from audience, like if someone can tell me, seeing this screenshot, if you would have got this 6 months back, what do you think, what could have you done with this screenshot? Anyone in the audience? Can you imagine like what it can lead to? Maybe a big thing? So I'll just tell. So this was basically, it led to a vulnerability in, this leaked a database which has 1 billion of police records in China, and then almost 23 terabytes of data was sold over on dark web. So you can just see that these hard-coded secrets in your source code, and one developer just put it on some developer forum, and then this was used to sold data on dark web. So it can lead to this much big thing.
Let's come to the second stage of the build pipeline. So the first stage is where you get the source code checked in. That could be a GitHub repo, GitLab repo, anywhere else. The second stage comes where the build part is. So in build part, usually you have Jenkins pipeline or GitHub Action, something like that, that helps you deploy, get the source code checked in, and create a compiled binary or let's say a container image, something of that sort. In the build stage, usually we check for secrets in the source stage itself so that nothing gets checked into the source code or the repositories itself. In the build stage, there have been scenarios where I'll just show you a screenshot in the next one. Yeah, this one. So here, there was no credential into the source code itself. Rather, there was secrets that was being logged due to the Jenkins pipeline, the tool that it was running. And this is a screenshot from one of my previous exploits from 3 years back. This company was more into betting and online fantasy dream sports kind of thing. So they had this Jenkins dashboard public up and running, and I couldn't find much in there, but they had these console logs for each of these builds that were automatically being built, and then those APKs were being shipped to the S3 cloud. So in one of the logs there, if you can see this green, I don't know if this works or not. Yeah, the third bottom green one, you can see there's a Slack credentials, and there's this channel of mstats dev alert. So there was some dev alert channel, but there were 2 issues here. First, there was a leak of the token. Second, the token was overly permissive. That allowed the person or anyone who has access to that token to access any of the channels in the whole Slack workspace. So I being the hacker in me, I access that token and try to access other channels and their eco in the workspace, and found one of the channel where there was a robot account that was trying to get AWS keys, and it was in a way dumping it on the, on the workspace itself. It was restricted to that particular account, but because this Slack credential had access to all of these workspace channels, so I got access to that, and using that particular credential, we got access to the S3 cloud where the whole source code was there. Eventually, this was fixed and this Jenkins was put down, but you can see that there was no secret added to the source code, yet your whole company could get compromised through it.
So now come the third stage, which is test. By this time, you want to test your application. So either you follow TDD or you're going to write the unit test after you have done code, but we all know that how many of us do TDD. But that's another thing. So yeah, so when we do, sometimes we write sanity test, integration test, unit test, but it's also important to write security test to catch some misconfigurations or even IDOR. So I just want to give an example. This was this was there published in Indian Express. There was a school student who could find a simple IDOR bug. He could just change some strings in the API endpoint, which leaked private information of one of the passenger who use IRCTC app. And we all know that there is million of people who use this IRCTC. If we would have taken care at our testing stage, this could have been prevented.
Yep, and that comes to the last stage of the pipeline, which is the deployment stage, and that's what we have been talking about all these while. So in the first source stage, we already got the source code checked in. In the build stage, we got it built. In the test stage, we are testing the binary. Now, this binary needs to go to the production environment. So you have a container image, you may be shipping it to your, let's say, Amazon EKS or a Docker Hub account or something like that. And the other thing you can do is you might be creating production infra using in the deploy stage itself. Let's say you are using infrastructure as code to deploy this whole thing, or you are using infrastructure as code to, let's say, deploy an S3 bucket, and on that you may be deploying a static website. So there could be two scenarios. For each of these, I'll be talking about some. So one of these, this is a Red Hat Lab research report, and so they were doing a research about Docker public repositories, and it's in the footer notes, I would say. So if you don't have a paid subscription for Docker Hub, your image by default is public. And this is what happened in one of the engagements where I was working. So what happened was one of the developers, he had the code of the repository that we were working, and he had his personal Docker Hub credential instead of the AWS EKS that we were working with, and accidentally pushed it to there. For a few months, no one noticed it, and then we started, once we saw this report, we started checking the online public repositories for our own code base, and that's where we found that this is what happened. So this is a very serious issue because it got us to change all the credentials. Some of the credentials were baked into the image itself, so that is something that you should never do. And we had to, if you see the stats here also, while they were doing this research, they found that around more than 1,500 of these public images. So if I remember correctly, they scanned a fraction of this whole Docker Hub because Docker Hub doesn't allow you to do mass scanning on their images. You can't pull all the images from all the repository and get it. There's no endpoint. So they played smart and they got hold of around, I think, 50 or 60,000 of these images. And from that, the stats is like over 1,500 of these images contain AWS credentials and then GitLab credentials, private keys, and whatnot. So all of these are very critical because they give straight access to your infrastructure, and these credentials, they don't require any 2FA or any other kinds of stuff in most of the cases. And you can see the hard-coded secrets as well. Yeah, next one. Yeah. So now we talked a lot about how we can, scare you rather, that, okay, this is getting leaked, this is getting leaked, all the 4 stages are compromised and whatnot. But we also are here to talk about some of the solutions, and we'll also be showing a demo of that. So let's talk about the protection around it.
Awesome. So yeah, that's true. We scared a lot. But this is a message that we should take security serious because the deployments are increasing. And I just want to mention one ratio. I just saw one talk yesterday while preparing for my talk. That there is always 100:10:1. That's roughly 100:10:1, where 100 are developers, 10 the other folks, and 1 is the security person. So you can see, like, with 100 developers shipping so much fast, we should try to automate our security as well. So let's talk about secure your source code. So you can use the tool Talisman, which is like a pre-commit hook. So before you commit your code to Git platform, it will check, it will scan for any misconfiguration or secret or credentials. Then you can also have security code scans by using some tools like SemGrep, SonarQube, CodeQuill. We also have a demo about it in the end. So you can have that in your CI pipeline, whatever you use, Jenkins, Tekton, or GitHub Actions, etc. Then third is securing GitHub commits with GPG signing. This is one of the things which I got to know while working with open source. Having the verified commits is quite important so that you're sure that you are the person. It's a surety that the commits have been done by you. Then secret scanning. So so security can be done at multiple layer. I know we have already used pre-commit hooks where we do secret credential scanning, but it's fine to do a multi-layer security. So you can use truffle hog as well for secret scanning.
Now, let's come to the build stage. So we saw in the scary example that there were build logs that were getting leaked, and we also saw that the artifacts that were creating, we also need to protect it. So in this one, we will be talking about how to secure your build itself and the build process. So the build process comprises of maybe GitHub action or your Jenkins job itself. So first thing is you need to have build logs that are secure. You don't need to basically check or scan it for any sensitive information if there's something. So either you can do it once in a while or you can continuously scan for any sensitive information, like you know what credentials you have in your whole account. So you can scan those for these scan logs. So that is one thing. I'll show you a screenshot as to how you can set it up for GitHub Actions. So yeah, let's just see this first. So in GitHub Actions, if you're using it for your own build pipelines, there's a feature called add mask, and you can mask anything that you provide. So let's say you provide the name Aseem Shrey. So, and if you add it as echo add mask Aseem Shrey, so if it ever comes in your whole log, that would get masked as star or something like that. But now you might ask, Aseem, but why would I put my secret itself in the first place? So that's not, so that's where you need to use the GitHub organization secret or your repo secrets. And let's say you know that, okay, this Android pipeline would require a Google API key, a branch live key, and let's say MO engage, maybe publisher account key or something like that. So you know that these three credentials are being required by you. So add those in the repo and add mask for these. So even if it accidentally gets leaked in any of these steps, it would automatically get masked. Can you go back to the previous one? Yeah. Then there are two other things that you need to take care of. First is that you need to sign your build. So for Android, it's a like mandatory process that the APKs need to be signed, and only then it can be pushed to your Android Play Store. The same goes for Apple as well. But for, let's say, binaries that you have created, let's say truffle log binary that the person is creating, so they need to sign that binary because that repo has, other people also have access to it and they can modify the binary on the fly as well. So for that to prevent any kind of tampering, that needs to be signed through the build process itself. And the last one comes where you can have application-specific binary scan. So for example, let's say you have a Golang binary or an Android binary. So you create this APK, now you would want to do some basic dynamic testing or static testing. So MobSF is something that we have been using. It's an open source tool called Mobile Security Framework. It gives a very comprehensive report about the different kinds of broadcast receivers you have, different kinds of strings you have, if there is any sensitive string hard-coded into your APK. If you are using a very insecure way of, let's say, AES encryption method. Let's say you have the AES encryption method for your communication, but you also are hard coding your credential or the AES key itself. So even that also gets tracked into this, and you can get a very detailed report in the HTML format, or even you can consume it in JSON format and then build automation around it. Hey, if there are 4 criticals or more than, let's say, 1 critical, then you can automatically fail the pipeline as well. So yeah, that's about this. Next comes the test stage. So we saw in the example in the IRCT's case where there was a very basic IDOR which leaked millions of people's data, and that was found by a school student. So a very basic testing of your application would help you suffice for it. I'm here particularly considering about web application because that constitutes majority of the application that's being deployed, but don't get biased by it. You can have dynamic testing and fuzzing for your binaries as well. Let's say your Rust binary or Go binary or any other kind of thing. So some of the common test cases that I suggest people to have is check for race conditions, because it's usually something that misses the eye of third-party vendors and even the majority of bug bounty hunters. So testing for race condition is easy for you in your own environment because you already know the gig. Then also test for security test cases which have already been reported to your company. So for example, you have a third-party vendor which does the pen testing on your platform. So you can have, while you have these reports and you have somewhere, let's say on a Jira or some other place, so you can have these, let's say, okay, this particular payment endpoint, it usually is to have IDOR. So you know that IDORs are very common in your API. So you would definitely want to check your new API that is going live. You would want to check IDORs for it. The other comes is authorization and authentication issues. So IDOR is also one of the authorization issues, and authorization and authentication issues can come into multiple places. For example, if you have SAML authentication or OpenID authentication, you would also want to check for those. It's a bit difficult to automate for that, but for IDORs, if you have the correct context, you can easily automate around it. Common tools of the trade, Nuclei by Project Discovery, it's an open source tool. In Nuclei, you can add, in a YAML file, you can add all the request parameters. You can also add all the response parameters that you would be expecting. So for example, let's say if you're expecting that this particular, let's say this particular response should be 201 or 403, but if you're getting a different response, you can raise an alert around it. Or let's say if in the response you're expecting that, hey, this particular endpoint ID/1 is Aseem Shrey. But if you are getting ID/2 and you're also getting response on that, you can flag it that there is an IDOR. You can do all these kinds of automation very easily using Nuclei. There's this OWASP Zap, which is an open source web proxy by OWASP tool. It's a very, very strong in a way that you can dynamically control it. You can add your own checks in a very simple JS format. It gives you some basic SDK so that you can interact with its APIs. We have been trying to, we have used it in my previous organization where we're doing dynamic scanning at scale around 20,000 plus APIs on a daily basis. So people can just upload a Postman collection, or while, let's say you are developing a feature and you know that this particular API, these particular endpoints would get hit. So you deploy it in your dev environment and then you upload a particular Postman collection using onto Zap, and then Zap could automatically test for all those test cases onto your dev environment deployed APK, dev environment deployed application. Third comes is the Burp suite, which is quite pervasive in the web application domain. It's a bit difficult to use APIs for it, and moreover, as far as I know, it's only available for the enterprise version, which is a bit costly. The only limitation that I see to this testing one is that it's limited to your test environment. So let's say I create a new payroll app, I deploy it in my AWS environment, in the test environment. This payroll app in the production would require to, let's say, interact with Bank of America and let's say Abu Dhabi Bank. But in my test environment, I won't be giving it third-party access. So unless I have proper abstractions created for those third-party APIs, it would be very difficult for me to test those attacks on the basis of third-party API interactions. So that is the only limitation that is in this stage.
So now comes the final stage, which is deploy stage. When your application is ready and you're going to deploy. So we have already done a lot of check before in the previous stages. But now in this stage, you will either have image build from the previous stages, or you might deploy to deploy as infrastructure as code in your infra. So how you can protect it? You have some tools like Chekhov. You also have a tool Trivi from Aqua Security, which can detect all the image misconfiguration or secrets in your containers. Now, I just want to raise one point that Aseem has already discussed about the research which was conducted by Red Hunt Lab. There we have seen that they had done a survey on publicly exposed Docker images in which there were secrets and credentials in the images which can be misused. So what you can do proactively to stop exposures in the Docker images, the first and the very simple thing is don't hardcode the tokens and the API keys in your Docker images. And if you need to access or authorize or even authenticate it, then maybe you can use environment variables, or maybe you can use tools like Vault, which we used to do at Grofers. Then the second step is do not clone or download the required files using credentials. Then a very simple step is having a Docker ignore file, so that you can ignore the Git directories or even your source code files. Yeah, and also one of the important things, it was mentioned that to share the Docker images, you can use private registries like AWS ECR or GCP. And we can see in the previous slides that when people were using Docker Hub, not the paid version, it was basically public, and so you can either use a paid version of Docker Hub. Okay, so cool. Now comes the demo time.
So this is the most secure app ever, and if you can see by the name, and you can see there are two folders, Diva Android and DVPWA. So Diva Android is a damn insecure vulnerable Android application, and DVPWA is the damn vulnerable Python web application. So not the most secure app, but yeah, we'll try to make it. So these are just these are public projects which are vulnerable, and I've just taken the liberty to copy the folder here to show a demo around it. What we are going to do is I'll show you 3 actions, GitHub actions. These are just the demo actions for this particular one, but you can do the same thing on your Jenkins pipeline or any other pipeline. So there's this Android security checks, there's a code scanner, there's a leaked secret scan. So we don't have a pre-commit hooks into this, but you can, in most of the cases, pre-commit hooks usually come when the organization is already big. So it makes sense to add pre-commit hooks to a new repo. And if you have to add to an old repo first, you need to remove a lot of those credentials which are already baked into it. So yeah, Android security checks, code scanner. So code scanner is, we are using semgrep for it, and we have a GitHub action around it. So I'm going to show a demo around it. I'll push a vulnerable code to DVPWA. And once I raise a PR, it should run as a mandatory check and should block it, apparently. Let me just clone this. I think I have already cloned this repo. Let me know if you are able to see the screen, or I'll increase the size. I think this should do. Yeah, the most secure app. Yeah, on main, yeah. Let me just be a good developer and check out a new branch. One code, not here. Cool code. I prefer using VS Code. I hope no one minds me using it. 1 second, yeah. So there's, let me zoom in a bit. Yeah. So here, it has a, I think this mic also is working fine. Yeah. So here's the SQLi folder which contains most of the code. So there's this views.py, and there's this routes.py. So I'd add a route which would help us to execute any command on here. I have it somewhere. I have it copied it here. I'll just copy paste it here.
Just a second, Aseem. I just want to ask, is it like, are we audible? Yeah, okay.
Yeah, the last person is raised, the man has said. Okay, so I'll just copy and add a vulnerable endpoint. So command w plus. So what it does is it slash command, and whatever command you pass, it would help us execute it. Now let me open this views.py. So what it does is it accepts the request, it checks the command parameter, which is command w plus. It basically adds to that, and then it runs os.popen with whatever command the user has added. Does anyone agree that this is not a secure way to code? So everyone agrees, kya? That's nice. I thought I was not good at coding. I have a few other people to say though. Okay, now let's open this. GST is short for get status, not the GST you pay. Get add dot. Sorry. Git commit -m adding secure code as per DevOps environment. DevOps days Janta. Cool, makes sense. Git push. I hope semgrep says git push origin one code not here. Where is that? Yeah. Now let's try to raise a PR here. Oh, this is actually I'm using someone else's account. Thanks, Vijay, for this.
Thank you, Vijay.
For making this happen. So it's not me coding something wrong. So yeah, this scan is already triggered. So this is a code scanner scan, and you can check the details. So I'll just show you how this has been set up here. So you can see that there's this GitHub action that automatically got triggered. You can set this up in settings. There's a branch protection rule that you can have. You can have as many branch protection rules as you want. And if you go to edit, see this is require status check. Oh. And here you can just, if you go, and let's say I type truffle hog. So you see there's this truffle log. So it shows only those checks which are there in the GitHub Actions. So because I'm not using currently truffle log, so I'm just removing it here from here. Let's go back to the PR. Yeah, this scan has failed and it's stopping the containers. 1 second, let me just go to the PR itself. All checks, check has failed. Now let me show you the SemGrep dashboard for this. I think this is not the account that I was using. This is not the account, no?
No, I think you can leave it.
Okay. Okay, never mind. Let me just show you it here. I wanted to show it on the dashboard, but even this is fine. This should show, yeah. Blocking findings, if you see here, and SQLi views.py, dangerous system call, found user control data used in the system call. It also mentions the resolution, use the subprocess module instead, which is easier to use and avoids accidentally any command injection. And here is the output which was the menu. You guys need to learn coding somewhere. Okay, so that was all the demo I had, and I think I should go back to the slides. Nothing much left, but yeah, if you have any questions around it, that would be awesome. Any questions? No. Cool. I think we are 3 minutes early.
My question is specific to like scan you mentioned.
Sorry?
You had a scan in that code, right? So similar to Snake, do you also scan NPM packages on pull request? Snake currently automatically checks our repositories for any outdated packages. So what do you have something on that, like any new packages that are coming in the PR? Do we scan? Can we scan that?
Just to clear, I am not a SemGrep sponsored person, but yeah, I don't know if SemGrep does that, but yeah, in my company we use GitHub Dependabot, and that in turn uses Snake's open database and other places as well. So that helps us check NPM packages and other kinds of things.
All right.
And that's a free one. Snake, I think, is not free. Yeah.
Okay, sure.
You mentioned about binary scan for Android application. Do we have some similar tool for iOS also?
Similar to MobSF, right? Like
yeah.
MobSF. I think I read some project. I would have to look it up. I'll send you. Ping me up on Twitter or somewhere. I'll send you back.
Definitely.
I'll figure it out.
Thank you.
Thank you, everyone.
Thank you so much.